So we've looked at the elementary operations in Matlab. We looked at some basic syntax, the use of the command window and the editor, and even the creation of functions. So now let's move on to something that's more specific to Matlab. All those other operations are common to any programming language. Let's look now at Matlab's features in creating vectors and matrices. First of all, to create a row vector with numbers that run in increments of 1, we simply use the statement 1:10, for instance, and that creates for us a vector that starts with the first argument there, 1, and ends with the last argument, 10, and it creates for us the values in between that increment with 1. So this is now a row vector that's being stored in answer here. We can access any element of this vector with the parentheses here. So let's say we wanted to access the third element of answer. Answer 3 there returns for us that third element. Now, of course, we quite typically want to customize the number of values that we have in between here. So let's say we wanted to go from 1 to 10, but in increments of 2. Then we can simply use here a third argument in this operation, 1:2:10, and now it will create a vector, but using increments of 2. And if we look at the result here, it started from 1, we've incremented with 2, and then it stops at 9 because when we increment by a value of 2, that would take us to 11, which is past what we've specified as being the end value. So that's how we can create a row vector in Matlab. Now, in mathematics in general, there's a bias towards column vectors. So we would like to be able to convert this default row vector very quickly and easily into a column vector, and to do that we can simply close this up in brackets and then use the apostrophe to transpose that vector. So we see here now a column vector which runs across the same values. So we can easily convert between rows and columns. We know answer is now a column vector, and if we were to transpose answer, then that would give us back a row vector. Of course, it is often the case that we know specifically what elements we want to use in our vectors and our matrices, and so we can specify those values using the square braces. Let's just clear the screen here, and let's create the vector A with the values 10, 20, 30 here. And so that creates for us this vector 10, which has the elements 10, 20, 30, and the usual operations apply. Now, if we wanted to create a column vector directly, what we could do is use the semicolon to specify that we want to go to the next line. So whereas previously we used 10, 20, 30 with just spaces between, or in fact we could use commas in between. Commas are also fine. So instead of using spaces or commas, if we used semicolons, then that would issue the statement to Matlab to please use the next row. So we'll see here, using the semicolons then forces that to give us a column vector. So this should in fact imply to you how we should be able to create our matrices. Right? If you think about it, that's enough information to create a matrix. And let's say we wanted to create a matrix with 10, 20, 30 on the top row and perhaps 5, 10, 15 on the bottom. Then we issue this statement, and let's use the normal maths convention, capitals for matrices. So if we were to say 10, 20, 30 on top, and then use a semicolon for 5, 10, 15, then you see we have the matrix here with the top row being that and the bottom row being that, and we had instructed the compiler to treat the following values, the values after the semicolon, as being on a new line there. So that's the semicolon. So we have our matrix A here. Any element in this matrix can be accessed in a similar way to how we access the elements for the vectors. So if we were to say A let's say we wanted the entry on the second row and on the, let's say, the third column, then we use it in the argument space to that variable. We use 2, 3, and you see it's returned here 15, so it's pointing to that element. So this is the convention in Matlab. The first dimension, or the first argument to a matrix, is the value down the column. So looking down the column at the row number, that's the row we're looking at. And the second argument is the column number. So looking across the row here for the appropriate column, we've pulled out the third column there. So that's the convention in working with your matrices. Note also that the transpose on this matrix is also defined, and it's the same command. So if we were to call up the matrix A and then just use the apostrophe to transpose it, then you see it has transposed the matrix A correctly. Now, when creating our programs and wanting to test them quickly, it's often the case that we'll want to create a matrix or a vector on the fly. We'll want to create something quickly and fill it with random numbers. So let's just do that using the rand command. So if we were to say rand, let's say we wanted a 3-element vector in the column space, then we'd say rand 3, 1, and you see that's a column vector of length 3. If we were to use rand on its own, if we were to omit the second argument, then it would treat it. The function would assume that we actually wanted a 3 by 3 matrix. So that's a shortcut in Matlab. You see here, rand 3 creates for us a 3 by 3. And that's something that is a little bit at odds with what we said earlier about requiring that every argument that's possible for a function has to be supplied to it. There are special declarations in which we can cause behavior to happen in which some of the inputs are optional. So anyway, in Matlab, the random function rand will, if we supply it with just one argument, assume that we want a matrix where that one value is used as the dimension on each side there. So that's the random function. We can use it to create any size of vector or matrix. Right? Obviously, we can create the rows there as well. So we specify we want 1 row and 3 columns, and then that's a row vector. So that's the rand command, very useful in testing our programs. Another very useful command which I often use in the creation of vectors and matrices is the linspace. So if we were to say linspace, and let's say we start from 5 and we want to reach a final value of 6, and we want to use, let's say, 3 points. Right, then this is the statement that we issue. Linspace is a built-in function in Matlab which accepts as its first argument the value that we wish to start that vector with. The second value is the value that we want to end on, and the third value is the number of points that it must use to get from the first value to the second value. So if we said linspace 5, 6, 3, we'd get 5, 5.5, and 6. Right, and obviously you can increase that to as many points as you like, and so on. You see here, by the way, in outputting this vector to the screen, we have more. We've required more points than it can fit on a single straight line there. So it's just wrapped around the screen to start the 8th column here. So according to the way I've spaced this window, we can wrap around to 7, and then it has to start again at 8 until we reach the value of 30 down there. You might also imagine that there's a logarithmic spacing that's possible, and yes, there is a log space command, another very useful one. So if we wanted to go from 10 to the power 3 to 10 to the power 4 using, let's say, 6 points, then that's the statement that we issue. So this is 0.1 times 10 to the 4, so that's 10 to the power 3. and then we want to end on 10 to the power 4. That's what the 3 and 4 mean there. That's actually 10 to the power 3, 10 to the power 4, and we want to do that using 6 points. So if you look at the 6 points here, you can see that those are logarithmically spaced. Something else that I find tremendously useful is that we can extract values from our vectors and matrices according to particular ranges, right? We said earlier that, well, let's create a vector quickly. A is 1 to 10, and let's just clear the screen. So we said that if we wanted to pull out the third value, we could do that using the value 3 there. So that's the answer of that. Now, let's say we wanted values over a particular range. Let's say we wanted values from the 3rd to the 6th elements of A. Then we'd simply issue the argument as being a vector of numbers. So in this statement, we're saying, take the vector A, pull out values from 3 to 6. Right? That's how we read these colons. Mentally, we can substitute the word 2 for that. So from the vector A, let's pull out all elements from the 3rd to the 6th, so up till and including the 6th. So that's what it's done there. So you can actually extract subsets from your vectors. Similarly, we could do that for our matrices. So if we recreated A here, it's bothering me a little bit that we've used a capital A for a vector. So let's create a matrix here. A is rand 5. And let's say we wanted to pull out from here, let's say these values. So this box here, and in this box we are looking at elements 2, 3, and 5, from rows 2, 3, and 5, and we want to pull out the 3rd and 4th columns for that. So then we would simply state here, A, in the first argument, in the row space, we want to pull out from 2 to 4, right, rows 2, 3, and 4, and we want to pull out the 3rd and 4th columns there. So we'd say 3 to 4. So if you look at this subset of those numbers, if you look up here, we've got in this position here, in that middle space, 0.9830 down to 0.4001, and then 7334 here, 0.009 here. So we've successfully extracted that part using the statement. So just by supplying the arguments of the